Hey, guess where I am? I'm in my living room talking math to myself. I think my neighbors think I'm nuts because I'm just babbling away. They don't know I'm actually taping myself, or I guess recording myself. All right, enough babbling by me. We are going to do the same thing as the last lesson, plus one more thing. So this is not much different. This is solving polynomial equations by factoring, so more than quadratics, so degree 3 or higher. And I am just going to work through 5 problems. Technically, this would be a 2-day lesson, but I'm just packing it all into one because I know that you can stop and start and rewind this as much as you want to. So my breaks will be for hand cramps only. All right, so I realize there's an equal 0 here. Do you? That changes very, very little. It changes your answer. It does not change your work. So we're going to start exactly the same way, and we're going to eventually solve for x. So a reminder, so mostly for me, more so than you, that means we need x equals a number as our answer. So when I look at this, first thing I'm going to do is ignore the equal 0, because I said we aren't doing much different. So I'm going to let the polynomial equal f at x. Then I'm going to remind you that there's the constant. So we're looking at trying the 1s, the 2s, the 3s, and the 6s. Now, I'm pre-planned over here in my living room, so I know that a number that works is 1. Now, the neat little test for 1 that I haven't mentioned up to this point is just taking the coefficients and adding or subtracting as they're sitting there, so ignoring the x's. So 2 minus 3 is negative 1. Negative 1 minus 5 is negative 6. Negative 6 plus 6 is 0. That means 1 works. So because I've done that test in my head and it works for 1, you can write that. Those are the 3 lines that are absolutely necessary to get yourself to a point where you can find one of the 3 potential factors. So now that we have a factor, I'm going to pause this so that I'm not taking up too much of your time. Whoa! I'm going to pause this and fill in the long division, synthetic division part, plus my division statement. See you in a bit. All right, so here I am. Done my long division with a remainder of 0. Yay me. Done my synthetic division, for those of you who like synthetic division, with a remainder of 0. Yay me. And with the exact same result for a quotient. So I've done kind of a little bit of a weird division statement here because I don't have the equal sign there. And this is where there's a subtle change from what we've been doing in the past. And that is, you do need to remember that this question is not a factoring question, it's a solving question. So I still need the equal 0 here, which is why I don't have an equal sign on the left. And that also means I have an equal 0 here. I should fix that 6. So next step is the same, except you will have an equal 0 on the right of that as well. So we have to take this 2x squared minus x minus 6 quotient, and we have to factor it. So we do still have to factor fully. So I'm going to set it up and then do my little scribblies. So 2 numbers that multiply to be 2, 2 numbers that multiply to be 6, 4, 3. I can make negative 1 in the center. This is negative, this is positive, so the positive is on the top for me, and the bottom for the negative. And my 2 brackets will be 2x plus 3, and the other one will be x minus 2. I still need to realize that this is 3 brackets long because I've got a 3. So potentially 3 answers, and they are going to be 3 distinct answers because they're 3 very different brackets. So you would think that that would be where you'd stop, and that absolutely is the case if this question is to factor. If it was to factor, you would not have the equal 0 sitting here. You'd have the equals sitting there, and you'd be done because you have factored as much as you can. However, with this question, it's solve. And you have the equal 0, which means you can go back to grade 10 or 11, or that first lesson, and give each bracket a 0. So this is that extra bit from the last lesson. And you can do as much of this mentally as you want. So everything that's written in green is optional. Everything that's written in black in here is part of the solution that's necessary. So x is equal to positive 1 from this bracket, so from this factor, or this one will be negative 3 over 2, or the third distinct different one is positive 2. And there you have your answer to the solve for x. So you have x equals a number. You've got a degree 3, so you're expecting 3 answers at the very, very most. So here is the second question. We're just going to do exactly the same thing. So with this question, I am going to take a little break, fill in some stuff, and come back and meet you at whatever number works. Remember your setup. So taking a little break by me. All right, so a reminder. This question is a degree 3 question. We are expecting 3 answers at the very most. Next thing. I'm so glad you weren't watching me struggle trying to find the number 3 that actually works for this, but 3 is a value for x that works. It's one of the 3 answers for solving for x. X minus 3 is a factor. So I've taken x minus 3 and long divided it into the original question and ended up with this quotient and ended up, thankfully, with a remainder of 0. So here's the original question, which you have no need to repeat. Here is the slightly factored version of the original question with the equal 0 that is really important. If you choose not to do long division, you can do synthetic division. So you would actually use the 3 rather than x minus 3, using all the coefficients. Once again, I've been super kind to you and me, because there are no gaps in this. It goes x to the 3, x to the 2, x to the 1, x to the none. So you don't have to fill any gaps. You don't have to do any rearrangements. You end up with the exact same quotient and, thankfully, a 0 remainder. So why would I have you do a question exactly like all the other questions we've been doing with that extra bit? And the reason is this. Try to factor this. You will be sitting there for days and you will not be able to factor x squared minus x minus 4, even though it looks like a simple trinomial. So the problem is you still have to find 2 answers for that bracket. Here is your third. So what you need to do is dig out the dreaded quadratic formula. So I'm going to do that now, painfully. A is 1, B is negative 1, C is negative 4. And I'm going to do this in purple just because it's a little bit different color than the red bigness here and the black that's here. So reminder that the quadratic formula looks like this. And I'm going to do this all in reduced radical form just to annoy you. But I have failed to mention up to this point in these videos that you may pick a school that doesn't let you use a calculator, in which case reduced radical form is where it's at. So you got to do your homework as far as your universities and colleges go. So minus 4 AC over 2A. So negative negative 1 is 1, plus minus. Denominator, 2 times 1 I can do quite easily. And this is 1 plus 16, which is 17. So I'm extremely excited because 17 doesn't break down for reduced radical form, so it already is in reduced radical form. So this is part of your answer, but it's not the full answer because we're expecting 3 answers, and this is 2 of them. 1 plus root 17 over 2, 1 minus root 17 over 2. So you have to go find your third, which actually is super easy to find. It's just super easy to forget. And there is my therefore statement with 3 answers. Now, if you're wondering why we don't just keep guessing and checking, guessing and checking, guessing and checking to find the 3 answers this way, it's because at no point would you ever guess either one of these 2 answers. So these are your 3 solutions. These are your 3 x values that will work in this statement to create a 0. So next question is this one. And I do want you to know that this one is a little bit trickier because I have left out an x squared term, which means when you get to the long division or the synthetic division, you've got to put the placeholder in. Other than that, there's no tricks. Might be a quadratic formula question. Keep your fingers crossed that it's factorable because now all of a sudden you might like factoring. So I'm just going to start. Remember that if you want to try it yourself, you can pause. You need this line in case you have to have this stressed. You need this line so that in your next line you can say, hey, guess what? I'm subbing in 2. Or whatever number you feel like trying. So it's a communication tool. I may have to backtrack, but there's your constant. So we were looking at the 1s, the 2s, and the 4s. In the last question, yep, I only had the possibilities of the 1s, the 2s, the 3s, the 4s, the 6s, and the 12s, which is why I struggled to find the 3. So now I'm going to do my little pause thing and fill in the long division and the synthetic division with my placeholder in both cases. I'll come back and show you what I mean in case you've forgotten. So you can see my hand cramping up as I go along here because I keep getting messier and messier, but I found that 2 works. That means x minus 2 is a factor, and if I choose to do the long division method, I need to make sure that I have the 1x cubed, 0x squared, then the negative 2x, then the minus 4. So I finished that. That is a hideous looking 2. Let me try that again. Here's my long division, and again, thankfully, I end up with a remainder of 0. If I choose to do synthetic division, I will have the 1 for the x cubed, the 0 placeholder for the x squared, negative 2 x's, and negative 4 numbers. I work with 2 rather than x minus 2. Remember, it's backwards. And I end up with the same result and the same 0 remainder. Here is my slightly varied division statement with the equal 0 to say that I'm about to solve. And at this point, I got super sad. And the reason I got super sad was because I can tell by looking at it that even though it's a simple trinomial, it isn't factorable. So x squared plus 2x plus 2 is a simple trinomial, but I can't find two numbers that multiply to be 2 that add to be 2 at the same time. So it's time for the quadratic formula. And again, I'm going to take a little break so that I can try to stretch my hand. And when I flip back, and you probably won't notice much of a difference, when I flip back, the quadratic formula will be filled in. If there's any reduced radical form, I'll be sure to explain it fully. So, time for a tell us break. Whoa, this one was a doozy. So, here's the original question with the equal 0. Here's the slightly factored version with an equal 0. Here's the quadratic formula, the a, b, and c from my trinomial bracket, me putting all the a's, b's, and c's in here, figuring out the denominator and the root, and realizing, oh crap, I've got a negative under the square root sign. Reminder that a negative under the square root sign causes you to have imaginary numbers. So the first thing I did is I pulled it out. So I've got an I, and the negative has disappeared. And then I got slightly excited because the root of 4 is just a nice little 2. So I put that in, and there's no roots, which is really nice. But 3 positions, so let me slightly highlight them in yellow. This one, beat it. This one, they can all be divided by the same number, and that is the number 2. So I divided by 2, I divided by 2, I divided by 2, and there is a 1 underneath that. That's 2 answers, not real answers, not graphable if we ever graph, which is coming next. Here's the third one, which is actually the first one, x minus 2 equals 0, unless you feel like doing that mentally. And there's 3 values. So that's not new. All of this is packed together, which makes it a little bit overwhelming, I'm going to guess. But we try to take it easy, teaching you little skill by little skill by little skill until we can pack it all together. So there are 2 more questions left. There is this one, which needs an equal 0 before you start. And there's this one. And both of these are super special questions. Both of these, I believe, you can do this way, finding a number that gives you 0, doing some division, factoring, or using the quadratic formula to solve. But I'm going to show you 2 little shortcuts for these 2 questions, 2 separate shortcuts, for those of you who can notice patterns. So this question has a pattern. And I also need to remind you that the unfortunate part about math, or for me, the fortunate part about math, rather than unfortunate, is that everything kind of fits together. So if you remember all the facts and you practice enough of them, you can actually find patterns that lessen your work. So here is my pause for a hand stretch. I'm back. So as I said, in order to do this question, you're going to have to make sure that you have the equal 0. So I did that in the first line. And yes, you can proceed like normal, but I want to show you something special, so I'm getting rid of that. Because if you take a look at this question without the equal 0 temporarily, you might notice that this is a difference of cubes. So a difference of cubes was in that first online video note, and a difference of cubes is what I like to call the keep it, change it, always plus. So I'm going to take this and I'm going to make my binomial size bracket and my trinomial size bracket, and before I forget, I'll put a 0. So a reminder of what this looks like. You cube root x cubed, which is x. If you want to, you can square it immediately and put it into the larger bracket. You can cube root 27, so cube root of 27 is 3. 3 times 3 times 3 is 27, and you can square that while you're at it if you choose. And then the middle of this trinomial is those 2 pieces of information multiplied together. Normally, it would look like 3x rather than x3. Then you go back to the original question, and you keep it, change it, always plus. Now, does anybody remember what I told you about this bracket? In case you've forgotten, this is not factorable. So it looks, again, like it's a simple trinomial, but it's not. You're going to have to use the quadratic formula. So this is where I take a break. Again, fill in the quadratic formula, explain some reduced radical form if necessary when I get back. You can try it now if you like. Okay, so here's my quadratic formula. There's my a, b, and c that I've stolen from this bracket. You do not need to write down the quadratic formula every time. I'm just doing it so you have reference. This is the quadratic formula. This is me putting the values into the quadratic formula. This is me cleaning it up. And then I went a little bit off to the side to break down my negative 27 under a root sign. So it's negative. That's how non-factorable it is. It's not even real. It's imaginary. So I took the I on the outside of the root, and I took it and put it there so that I don't have the negative under the root. Then the root of 27, I can break that down using the perfect square of 9. That's the largest one. 9 times 3 is 27, so root 9 times root 3 is root 27. Fortunately, root 9 is so special that you can take the square root of it perfectly and get 3. So you get 3i root 3. I substituted that back in, and thankfully, these three numbers are not divisible all by the same number, so I have to stop. Then I have to collect my third answer, because this was originally a degree 3. And you might be sitting there thinking to yourself, well, how is this a shortcut? This is a long question. Well, the shortcut is that if you take a look at this question versus every other question we've done, so all three of them, the part that you get to avoid if you notice the pattern of a difference of cubes, or in the case of a sum of cubes, you get to avoid doing the f at x business, finding your number. You get to avoid long division, or if you prefer, you get to avoid synthetic division. So again, this one, you found the number, you had to long or synthetic divide. This second last question that we've done, you had to find the number, long or synthetic divide. This one, you didn't have to find a number, you didn't have to long or synthetic divide, you just went straight to the quadratic formula because you noticed a pattern. Hopefully you do notice that pattern. This is pretty typical. So the next question is my favorite kind of question. So I call these the Wayne Gretzky questions. And I call them the Wayne Gretzky questions because Wayne Gretzky was the best hockey player ever, and he used to know things that nobody else knew. So I'm trying to teach you something that nobody else knows. So this is our little secret, which is now pretty public because I'm making a video about it. So yeah, you can proceed like you normally would. You can call 3x cubed plus 15x squared minus 4x minus 20 f at x, and then you can find a number that divides into 20 that gives you a 0. But I do want you to know that there is a shortcut to this question as well. You could potentially try this with every question, but some questions are going to work and some questions aren't going to work, and I'll tell you how you notice, but you need a line or two of work, or at least mental figuring, to figure it out for yourself. So another way to do this is the lightning bolt. So we kind of did this in factoring by grouping earlier. So you split it after 2, and now you pretend like the back half doesn't exist and you factor what you can out of the front half. So I can take a 3 out of 3 and 15. I can take an x squared out of x cubed and x squared and leave behind an x, a plus, and just a 5. Then you forget the front half exists and you go to the back half. Now you don't want to cheat and make this work. You want it to work naturally, otherwise it's wrong. So out of the back half, without looking at what I've got written down here, I can take out not a 4, but a -4. And if I take out a -4, that means I'm left with just an x, and -4 divided into -20 is +5. And then I still have to remember the equal 0. And it is a Wayne Gretzky question. When your brackets are identical. If they are not identical, your job is to go back, find the number, long divide, or synthetic divide. But fortunately, this one works out very nicely. So next step is, just like factoring by grouping, which is really what this is, drag the x plus 5 forward, and then in a bracket behind, put all the stuff you haven't written down yet. So this and this. Don't be tempted to square this bracket, because that will turn this into a degree 4. So if you square this bracket, you'll have x squared, and another x squared gives you x to the 4th, and it has to remain an x to the 3 question. So make sure that a degree 3 question continually remains a degree 3 question. This is quadratic formula-able, if that's actually a term, but I want to show you the dangerous method again. So with that question, or that part of the question, use my little green pen, I'm going to take x plus 5 and equal it to 0, which will be really easy to solve, and 3x squared minus 4 equals 0. Now I can only pull this off because there's no b term. So I'm going to take the 4 across the equal sign, and then I'm going to divide both sides by 3. So I end up with x squared is equal to 4 over 3. I still have to get x by itself, so that means x will be the square root of 4 over 3. And I can go a little bit better with that and tell you that x is equal to the square root of 4, which is 2, over the square root of 3, which I can't figure out in my head, so I leave it alone. And if you're sitting there thinking, hold on a second, I thought we were supposed to have 3 answers, don't forget you still have this one. But hold on a second. That's 1, 2. Where's the third for the degree 3? And the third comes from the fact that if you've lost it, you've lost the plus minus. And there's 1, 2, 3. So normally, like I said off the top, this would be 2 notes. It's all the same topic. I would have separated it into a note with this long / synthetic division question, the second long / synthetic division question, and the third long / synthetic division question, and then I would have shown you the 2 Wayne Gretzky questions in the next one. So just so you know how this is slightly different. Be careful when you're doing this stuff. When I ask you to omit questions, like in this case, don't do 5D and don't do 11D, I actually mean that for your own good. So don't challenge yourself unless you absolutely want to. And sometimes it's just because the questions are blurry. So it's not because I don't think you can handle it in some cases, but if it says omit, there's probably a good reason for it that I just haven't memorized for this particular question, or set of questions. So good luck with that. We are done this section, and we're going to move on to why on earth do we do all this stuff? So one of the many reasons, one of your reasons could be because you need to get to calculus, and that is a personal reason. I'm not sure I know your answer, you should probably know your answer. Even if it's just, I love math and I want to learn as much as possible. So there you have it. Whoa, that's good timing by me.